periodic table of elements. So it says here that we've got a total of 116 elements. There's actually a few more now, but basically we've got just over 100 elements. And an element is a substance that contains only one type of atom. So all the elements are collected together in this periodic table, and they're listed by atomic number. Atomic number is this number along the bottom here, and it tells you the number of protons in an atom. We'll talk about what we mean by that in a minute. And they all have their own symbol. Really important to notice that each symbol has a capital letter at the start. So if you see a capital letter, you know that that's a new element. So if you've got C and then an O and they're both capital letters, that means you've got carbon and oxygen. Whereas if you have C and then a lowercase o, then you know you've got cobalt. And the number along the top in this periodic table is the relative atomic mass. And again, we'll talk a little bit more about that in a minute. Over this side of the periodic table we have the metals, and over on the right hand side we have the non-metals. Okay, when elements react together, this is a really simple representation here. There's usually a detectable energy change, and when that happens we form a new substance, and the new substance is called a compound. So elements react together to form compounds, which are substances made from different elements that have chemically bonded together. Again, really important here that you understand that this is a simple representation, but we've got the language here. So we have atoms. Atoms join together to make molecules. Now these molecules could be elements still, because we've only got one type of atom, or they could be compounds. Here we've got a molecule that is also a compound. If this were a metal joining to a non-metal, then you wouldn't form a molecule, but we'll talk about that later. And you need to be able to assign chemical formulae to compounds. So, for example, here we've got a couple of H's joined to a couple of C's, so C2H2. See if you can match up the other ones. So we've got NO2, and we have CH4, and we have NO3 or H2O. So it's really important again to notice that we've got a small subscript number here to show how many atoms are joined together to other atoms within a compound. Okay, more about formulae here. This molecule here is CH4, but if we have two lots of CH4, then we wouldn't call this C2H8, we'd have to put a large 2 to show that we've got two separate lots of CH4. How many oxygen in each of these compounds? So in here we've got one oxygen, here we've got two lots of oxygen, everything's multiplied by 2, so two lots of oxygen here. Here we've got two oxygens again because everything in the brackets is multiplied by 2. Here we've got three lots of oxygens here, but we've got three lots of the whole thing. So altogether we have 9 oxygens. Here we've got 4 oxygens, that's fairly straightforward. Here we've got 4 oxygens here, but there's 3 lots of the whole thing, so we've got 12 oxygens altogether.